morning students. Let us have continuation of algebra of limits in that last theorem that is related to division. So in this two proofs they may ask. Okay, so for that same proof is there. See here question. Two different types they may ask. Limit of g of x as x tends to a equals to m. M is not equals to 0. Limit of 1 by g of x as x tends to a equals to 1 divided by m. So this is one question. Here m is not equals to 0 condition is there, because if m equals to 0, 1 by 0 it is infinity. Okay. So another proof, limit of f of x by g of x as x tends to a equals to limit of f of x as x tends to a divided by limit of g of x as x tends to a equals to 1 divided by L divided by m. So in order to prove this result, first you have to prove this. Okay. So this proof is so up to this end. So that is the first one. So in that only if you substitute that value, so we get the second one. So for these two proofs you have to refer the same proof. Okay. So consider limit of f of x as x tends to a equals to L and limit of g of x as x tends to a equals to m. L and m value you have to consider. So in order to prove this result, first you have to prove that limit of 1 by g of x as x tends to a equals to 1 by m. First one we have to prove that. In that only if you substitute the value, so we get the second result. So according to that similar previous theorems, so we have to consider 1 by g of x minus 1 divided by m. Here it is division is there, so we have to consider 1 divided by m. If it is multiplication, there we have to consider f of x into g of x. In addition, it is addition and subtraction. Okay. So take the LCM, m into g of x. Here it becomes m and multiply 1 by g of x, m minus g of x. This is equals to g of x minus m. M minus g of x can be written as g of x minus m, because if you take the minus sign outside, the terms will be interchanged. That is minus of a modulus is equals to plus modulus. So for that purpose, so we have written g of x minus m, both are equal, because in modulus minus a should be plus. Then in order to separate the modulus for numerator and this term, so we have to put the sign less than or equals to. If the sign is less than or equals to, modulus should be separate. If modulus is separated, we have to put this sign as less than or equals to. So call this as equation number 1. In this equation number 1, we have to find the values of modulus of g of x minus m and modulus of m and modulus of g of x. So those values we have to substitute in this equation, we will get the required result. Okay. So in order to prove that, so consider limit of g of x as x tends to a equals to m. According to limit definition, epsilon 1 greater than 0, there exists delta greater than 0 such that modulus of g of x minus m is less than epsilon 1. So this is the condition, call it as equation number 2. So this we are writing according to definition of limit. So this is the value of modulus of g of x minus m is less than epsilon 1. So here in this, here we have to substitute that value epsilon 1. Next, modulus of m. So this value have to calculate. Consider modulus of m is equals to m minus of g of x plus g of x. Here, one is subtracted, one is added. By cancelling these two, again you will have that same equation as in LHS. Okay, so it means that both are same. If you separate the modulus, again the sign should be less than or equal. That is m minus g of x plus g of x. Modulus are separated, sign should be less than or equal. And again as similar to that, minus of a modulus is equals to plus a. Here by taking the minus sign outside, it becomes g of x minus 1. Modulus of minus a is equals to plus a. So it becomes g of x minus m. So this is as it is. Therefore, modulus of m is, we are considering this modulus of g of x m, that is epsilon 1. That is epsilon 1 plus g of x. Choose this epsilon 1 value, choose this value as 1, so it becomes 1 plus modulus of gx, call this as equation number 3. So this is modulus of m equals to 1 plus modulus of gx. So that value we have to substitute in modulus of m. Substituting these two values, 2 and 3 in equation number 1. So by substituting that value, we get this epsilon 1 divided by 1 plus modulus of g of x into modulus of g of x as it is. Multiply this g of x into 1 modulus of g of x plus modulus of g of x into g of x, that is whole square. So call this as equation number 4. Okay. So here you have to choose the value for epsilon 1. For this you have to choose the value of epsilon 1 is equals to epsilon into modulus of g of x plus modulus of g of x whole square. Then the equation 4 becomes, on substituting that value, so this is LHS, that should be less than epsilon because that value cancels with, so this denominator term, numerator and denominator get cancelled, so it should be less than epsilon. So modulus of 1 divided by g of x minus 1 by m is less than epsilon. So applying limit, if you apply limit to this, so it becomes limit of 1 divided by g of x as x tends to a is equals to 1 by m according to definition of limit. If modulus of xn minus l is less than epsilon, limit of xn as n tends to infinity equals to l. Okay, so in place of l it is 1 divided by m. 1 by m means m you are considering as limit of g of x as x tends to a. Okay, that is 1 divided by limit of g of x as x tends to a. So this is the proof related to first one. So for that second one, limit of f of x by g of x as x tends to a can be written as, separate the numerator and denominator. Numerator is limit of f of x as x tends to a into this denominator term 1 divided by g of x. Limit of 1 divided by g of x as x tends to a. Limit of f of x as x tends to a you are considering as L. So this term you are considering as L, and this you have already proved, that is 1 divided by m. So that is 1 divided by m. So it becomes L divided by m. Therefore limit of f of x by g of x as x tends to a is equals to L by m. L as limit of f of x as x tends to a, and m as limit of g of x as x tends to a. So this is also an important theorem. Okay.